Students, welcome to the class. In the last class, we discussed about the force between two parallel conductors carrying current. We discussed it, and we discussed the definition of 1 ampere. We discussed it, right? So, in our today's class, we are going to discuss about once again very important topic. That is torque on a rectangular current loop. Torque on a rectangular current loop in a uniform magnetic field. In uniform magnetic field. In a uniform magnetic field. Right. See here, if I am going to consider the current in this direction, the current is in this direction. If the current is in this direction means, so this becomes magnetic direction also. So here this becomes south. If the clockwise direction is their current, if this is clockwise direction, right? If the clockwise direction the current is there, so this becomes south pole. This becomes south pole. Why? Because, sir, why you are going to take north and south? Because the magnetic field is there here. Magnetic field is there. So this becomes what? North. This becomes what? North. If the current is in clockwise direction, so this becomes what? South. This becomes what? North. Right? Here the magnetic dipole moment is also coming. That is what? Magnetic dipole moment is equal to IE. Right? So IE means the product of or the cross product of current into what? This area. This current into area is called what? Magnetic dipole moment. Magnetic dipole moment. This we go through first. Getting my point? So here, if the current is in clockwise direction, this side becomes south. Right? So this becomes what? North. Clear this one, right? After this one, now I am going to consider right. So this is north, this is south. This is north, this is south. Now I am going to consider a rectangular loop here. A rectangular loop. See, like this. Alright. So the current is flowing in this direction. Now I am going to take this what? A, B, C, D. A, B, C, D. Right. See here, the current is going like this, going like this, again going like this, and here this. So the coming back is like this. After that, so here see the ABCD is having the length B, and this BC and AB having length what? A. This is length is L. Its length is L. Its length is L. Right? So here what we consider? We consider a rectangular loop. Consider a rectangular loop carrying current I such that so what AB is equal to CD is equal to D. AB BC CD is equal to AB and what BC is equal to AD is equal to A. BC is equal to AD is equal to A. Right? Next one. See here what happens. Here one of the very important one. So here I am going to take this diagram for like this. Right. So see here, this is our magnetic field in this point. From here to here, from here to here. This is the magnetic field direction. And this is magnetic field direction. Right. See. Now I am going to take the forces. How we are going to take the forces? See, in this case also I am going to take the force. In this length also I am going to take the force. In this length also I am going to take the force. In this length also I am going to take the force. Right? So here the force. See, the force of magnetic field. Now I am going to take AD, right? So FAD. See here FAD, or otherwise you have to take AB. Sir, AB in the start part, AB in the start part. So we know what BIL sin theta. BIL sin theta. Right? See, the current direction is here, right? The magnetic field direction is in this direction. So both are in opposite direction. So then the angle between this and this, how much it is? Theta is equal to 180 degree. Theta is equal to 180 degree. So then FAD is equal to BIL. Sin 180 means what? 0. So then here FAD is equal to what? 0. So this is first force. Right. Then coming to the what? I am going to take this one. Right? BC I am going to take. FBC is equal to FBC. Right? See here once again. BIL sin theta. See here once again. The current direction is the magnetic field direction is this direction. This what? The current direction is also in same direction. So the angle between these two, how much? Theta is equal to 0 degree. L2 ಒಂದ ಕಡೆ ಹೊಂಟಾವ್ರಿ. L2 ಒಂದ ಕಡೆ ಹೊಂಟಾವ ಅಂದ್ರೆ theta ಎಂತ 0 degree. Right? So BC is equal to BIL. ಲೆಂತ್ ಏನೈತಿ? E ಅಂತ ತಗೋಬಹುದು. ಇಲ್ಲಿ E ಅಂತ ತಗೋಬಹುದು. ಎಲ್ಲಾನು 0 ಆಗ್ತೈತಿ. Right? A into sin 0 ಅಂದ್ರೆ ಎಷ್ಟೇ? Sin 0 ಅಂದ್ರೆ 0. So then FBC is equal to what? 0. FBC is equal to what? 0. ಪಾಯಿಂಟ್. ಸೊ ನಾವು ಹಿಂಗೂ ಮಾಡಬಹುದು ಏನ್ರಿ, ಒಂದು ಈ ಡೈರೆಕ್ಷನ್ ಐತ್ರಿ, ಒಂದು ಈ ಡೈರೆಕ್ಷನ್ ಐತ್ರಿ, ಬೋತ್ ಈಕ್ವಲ್ ಅಂಡ್ ಅಪೋಸಿಟ್ ಫೋರ್ಸಸ್ ಆಲ್ಸೋ ವಾಟ್ ಕ್ಯಾನ್ಸಲ್ ಅಂತ ನಾ ಏನು ಮಾಡಬಹುದು ಮೆನ್ಷನ್ ಮಾಡಬಹುದು. ರೈಟ್. ಸೊ ಎಫ್ ಎ ಡಿ ಮತ್ತು ಬಿ ಸಿ ಬಿಟ್ಬಿಡ್ರಿ, ಎಫ್ ಎ ಡಿ ಮತ್ತು ಬಿ ಸಿ ಬಿಟ್ಬಿಡ್ರಿ. ರೈಟ್. Now coming to these forces. Now coming to these forces. Right. So when we are going to apply the force onto the AB, see, force. One sentence very important. The forces in the arms. The forces in the arms BC and AD, BC and AD are equal and opposite, or equal and opposite. One forcing hogtidri, one forcing hogtidri. So that equal and opposite act along the axis of the coil. Act along axis of the along axis of the coil. They cancel out, they cancel out each other, then net force is zero. Then the net force is what? Zero. Right? Very important. Right. After this one, I am going to take, see, next one. Here what happens? The magnetic field is in this direction. The magnetic field is in this direction. The current direction is in this direction. The current direction is in this direction. So the angle between the current and magnetic field becomes how much? 90 degree. The angle between current and magnetic field is equal to how much degree? Right. So the force on magnetic field, what? AB. AB. So then F AB is equal to what? Will sin theta. Right. We know theta is equal to how much degree? Theta is equal to how much degree? So then F AB is equal to B I. What is L? L is equal to B. L is equal to what? B. Getting my point? So then sin B, right? Sin theta, sin 90 is equal to how much? 1. So this is our FAB. This is our FAB. Getting my point? Right. Now see, once again, here coming to the what? CD. The magnetic field is in this direction. The magnetic field is in this direction. Right. So the current direction is in this direction. So once again the angle between theta is equal to how much degree? 90 degree. So once again I am going to write FCD is equal to Bill sin theta. Bill sin theta. So once again theta is equal to 90 degree. Once again theta is equal to 90 degree. So then FCD is equal to BIB. What is our length here? Here also B. So right. So then sin 90 is equal to what? 1. Sin 90 is equal to what? 1. Right. See here. See here. In this case, what happens here? The force is applying like this force. So here this force is applying this case by the left hand Fleming's law. By left hand Fleming's law. Right? Yakandra. So here these two forces, ಈ ರೀತಿ ಇದ್ದು ಈ ಫೋರ್ಸ್, ರೈಟ್? ಈ ರೀತಿ ಇತ್ತು, ಇದು A, ಇದು A, ರೈಟ್? ಸೊ ಇಲ್ಲ ಈ ರೀತಿ ತಗೋತೀರ, ಇದು B ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. A ಈ ರೀತಿ ಇದ್ದಿದ್ದು ಏನಾಗೈತಿ? ಈ ರೀತಿ ಆಗೈತಿ. ಒನ್ ಫೋರ್ಸ್ F1, ಇದು ಏನ್ರಿ? F2 ಫೋರ್ಸ್. ಕ್ಲಿಯರ್? ಸೊ ಇದು F1 ಫೋರ್ಸ್, ಇದು F2 ಫೋರ್ಸ್. ಸ್ಟಾರ್ಟಿಂಗ್ ಈ ರೀತಿ ಇತ್ತು ರೈಟ್. ಸೊ ಯಾವಾಗ ನಾವು ಫೋರ್ಸ್ ನಮಗೆ ಸಿಕ್ತ ಸೊ ಆ ಫೋರ್ಸ್ ಒಂದು ಈ ಕಡೆ ಬೀಳಾತೈತಿ ಒಂದು ಈ ಕಡೆ ಬೀಳಾತೈತಿ ಒಂದು ಈ ಕಡೆ ಬೀಳಾತೈತಿ ಒಂದು ಈ ಕಡೆ ಬೀಳಾತೈತಿ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ what rotates. It starts to what rotates. It starts rotates means what the net force is what creating, producing torque. The net force creating what here torque, right? So here that's why see this is our area. Starting over think it. So ಇದು magnetic field right. ಇದು ಏರಿಯಾ ಸಾರಿ ಇದು ಏನಿದೆ ನಮ್ದು ಎ ಡಿಸ್ಟೆನ್ಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಇತ್ತು ಇದು ಏನಿತ್ತು ಏರಿಯಾ ಇತ್ತು ರೈಟ್. ಸೊ ಇದು ಏನಾಯ್ತು ಸ್ವಲ್ಪ ಟರ್ನ್ ಆಯ್ತು ರೈಟ್ ಸ್ವಲ್ಪ ಟರ್ನ್ ಆಗಿದ್ರೆ ಈ ಏರಿಯಾ ಈ ಕಡೆ ಬಂತು ವಿತ್ ದಿ ಆಂಗಲ್ ಆಫ್ ಥೀಟಾ ವಿತ್ ದಿ ಆಂಗಲ್ ಆಫ್ ವಾಟ್ ಥೀಟಾ ಇಟ್ ಮೈ ಪಾಯಿಂಟ್. ಸೊ ಸಮ್ ಆಂಗಲ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತೀವಿ ಇದೇನು ಕ್ರಿಯೇಟ್ ಮಾಡ್ತೀವಿ ಸಮ್ ಆಂಗಲ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತೀವಿ ನೋಡ್ರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ದಿಸ್ ಇಸ್ ಥೀಟಾ creating by what A with the what magnetic field. See here this complete becomes how much 90 degree and this one only becomes 90 minus theta right. Now I am going to take see here I am going to take once again. So here this is the magnetic field. So this is our force. This is F1. This is F2. Right. So here now I am going to produce up to here. Here also I am going to produce like this. Right. Here this is the area. This is the area with the angle of what? Theta. So this complete is how much 90 degree. So then this one already theta is there. This one is how much it becomes 90 minus theta. Now see if this is 90 minus theta, this one is also becomes what 90 minus theta. Here once again this is what 90 degree. This is what 90 degree. Here that is what theta. Here what that is what theta. Now what I am going to take the theta so first see here I am going to take if this becomes like this this complete is how much A. If this is half means this is A by 2 this is A by 2. Get my point? If this is curve means it is coming like this. ಇದು ಇಲ್ಲಿ ಬರ್ತದೆ this becomes what A by 2. This becomes what A by clear my point right. So nanaga idu ಬೇಕು ಏನು ಬೇಕು ಇದು ಬೇಕು right ಏನೋ ಹೆಸರು ಕೊಡಿ P Q ಇದು ಕೀ ಅಂತ ಕೊಡಿ right. So from what A P Q triangle what perpendicular divided by hypotenuse so perpendicular ಅಂದ್ರೆ ಏನೈತೆ PQ ಐತಿ divided by hypotenuse ಅಂದ್ರೆ ಏನೈತೆ AQ ಐತಿ right. So next so sin theta is equal to PQ right divided by AQ is noted A by now what we want PQ. So E distance taken PQ is equal to what sin theta. So sin theta sin A by 2 even ನಮ್ಮ sin A by 2 ಇಷ್ಟು ನಮಗೆ sin theta ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ ಏನು ಸಿಗುತ್ತೆ sin theta ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ ರೈಟ್ sin theta A by 2 ಗೊತ್ತಾಗುತ್ತೆ. Now we are going to take the two forces are equal and opposite. The two forces are the two forces are equal and opposite but not collinear. ಒಂದು ಕೋಲಿನಿಯರ್ ಇದೆ ಇಲ್ಲಿ ಕೋಲಿನಿಯರ್ ಇದ್ದರು ಬಟ್ ಇಲ್ಲಿ ಎರಡು ಫೋರ್ಸ್ ಈಕ್ವಲ್ ಅಂಡ್ ಅಪೋಸಿಟ್ ಇದಾವೆ, ಒಂದು ಈ ಕಡೆ ಈ ಕಡೆ, ಬಟ್ ಕೋಲಿನಿಯರ್ ಇಲ್ಲ, ರೈಟ್. ಸೊ ಹಿಯರ್ ಈ ಕೋಲಿನಿಯರ್ ಇರ್ಲಾರ್ದಕ್ಕನ these forces forms a couple. These forces forms a couple, and the loop experiences what? Torque. The loop experiences what? Torque, right? So torque is equal to force into perpendicular distance. Force into perpendicular distance. ನಮಗೆ ಏನು perpendicular distance ಐತೆ ಅಂತ ನಮಗೆ ಗೊತ್ತಾಗ್ತದೆ, right? So here torque is equal to torque. So torque is denoted by tau. Torque is denoted by what? Tau, right? So once again, tau is equal to what? F AB plus this one F CD, right? So then the magnitude of torque of the loop is the magnitude of torque of the loop is the magnitude of torque of the loop is, so torque is equal to right there. F AB value ಏನು ನೋಡ್ರಿ, F AB value ಏನು ನೋಡ್ರಿ. So BIB, so sin theta A by 2, sin theta A by 2 plus BIB sin theta A by 2, sin theta A by 2, right? Next ನೋಡ್ರಿ ಏನಾಗ್ತದೆ ಅಂದ್ರೆ once again torque is equal to ಎರಡು ಸೇಮ್ ಅದಾವೆ, ಸೇಮ್ ಅಂದ್ರೆ ಎಷ್ಟು ಆಗುತ್ತೆ 2 BIB, right? sin theta A by 2, sin theta A by 2, right? So next ನೋಡ್ರಿ ಏನಾಗುತ್ತೆ, these two got cancelled. Next I am going to write torque is equal to BI, right? AB sin theta, BIAB sin theta, right? Next now the equation is now I have to once again torque is equal to B, right? AB, right? AB. So AB ಅಂದ್ರೆ can I write area is equal to length into breadth? So what is our length? So what? B. What is our breadth? A. So then can I take that one what? A. So then A sin theta, right? So next here torque is equal to ಈ ರೀತಿ ಬರೆಯಬಹುದು BIA sin theta, ಈ ರೀತಿ ನಾವು ಬರೆಯಬಹುದು. So if for n turns what happens? Torque is equal to NBIA sin theta. N add this is our torque. Right? This is our torque for reference. Where theta is the angle between where theta is the angle between theta angle between normal to the loop, normal to the loop and magnetic field, and magnetic field. Next, here torque is equal to mb sin theta, mb sin theta. Here what? M is equal to N I A. M is equal to what? N I A. Magnetic dipole moment. Magnetic dipole moment. So N number of turns. Right? N I M B sin theta. Right? In vector form, torque is equal to, so sin theta ಏನಾಗುತ್ತೆ m cross b, m cross sin theta is equal to m cross b, right? So where m is equal to n I a is called magnetic dipole moment, where NIA is called magnetic dipole moment or magnetic moment of current loop, or magnetic moment So here the SI unit of magnetic moment, the SI unit of magnetic moment, the SI unit, the SI unit magnetic moment, the SI unit of magnetic moment is, the SI unit of magnetic moment is, ನೋಡ್ರಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಅಂದ್ರೆ ಎನ್ ಐ ಐ ಅಂದ್ರೆ ಕರೆಂಟ್ ಆಂಪಿಯರ್ ಪರ್ ಏರಿಯಾ ಅಂದ್ರೆ ಮೀಟರ್ ಸ್ಕ್ವೇರ್, ಆಂಪಿಯರ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್, ಆರ್ ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ರೈಟ್ ಆಂಪಿಯರ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಲೈಕ್ ದಿಸ್, ಆಂಪಿಯರ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್, ಆಂಪಿಯರ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್. After this one, when theta is equal to 0, when theta is equal to 0, so this is note number 1, this is note number 2. When theta is equal to 0 degree, torque is minimum in that one direction. Value when theta is 0, so torque is equal to mb sin theta. So torque is equal to mb sin 0 degree, right? Sin 0 degree is equal to 0. Sin 0 degree is equal to 0. So then torque mb sin 0 is 0. So torque is 0. So torque is minimum. Right. So next, third one, when theta is equal to 90 degree. Theta is equal to 90 degree. What? torque is equal to mb sin theta. Torque is equal to mb sin theta. So then torque is equal to mb sin 90. So here what sin 90 is equal to 1 and 90 is equal to 1. So torque is equal to mb. Torque is equal to mb. So then torque is maximum. Torque is maximum. Torque is maximum. Right? So ಇದು ಎರಡು ಒಂದು ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ this is b, this is m. So ಇದು b ಇದ್ದಾಗ ಇದು ಏನಿರ್ತದೆ ಈಗ m ಇರ್ತದೆ. So what 90 ಗೊತ್ತಿರಬೇಕು. So this is about torque on a rectangular current loop. Torque on a rectangular current loop in an uniform magnetic field. In an uniform magnetic